Rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Hi there. So we are going to be taking notes on this sheet, which hopefully you grabbed in class, just because there are a lot of examples and I don't want to waste time copying them down. So we'll take notes first on here, and then at the end of class, or at the end of the video, I guess, you can glue them into your notebook. The essential question and the table of contents information are all on that first little screenshot of the video, so you can go back and do that on your own. For now, we're going to take this paper and we're going to fold it in half like this and make sort of a book out of it so that we can glue the back of it into your notebook. So we're going to start by just reminding ourselves what we learned last class. We learned that if two figures are similar, and remember that's our little symbol for similar, if that's the case, let me zoom in here, then the corresponding angles are, hopefully you remember, congruent. And then if two figures are similar, their corresponding sides are not congruent, they are proportional. And that means that if we set up a proportion with the side lengths, it'll work out. So the problem is we don't always have every side length and every angle to show that all the angles are congruent and all the sides are proportional, and we don't need all that information to know that two triangles are similar. So it turns out that knowing that two corresponding angles are congruent is enough. And so this is going to remind you a little bit of the triangle congruence shortcuts, but these are triangle similarity shortcuts. So AA says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So in this situation, we're just going to mark up an example. Let's say that these angles are congruent and these angles are congruent. That's enough to show that the triangles are similar. Obviously, if we know these two, then we could subtract them from 180 to find the third, and the third angles would be congruent as well. And if you have all the angles congruent in a figure, then you're going to have similar figures. So that's enough. Let's look at the second shortcut, side, side, side. So if the three sides of one triangle are proportional to the corresponding sides of another, then the triangles are similar. So we also had a side, side, side congruence theorem, but that was if the sides are all equal to one another. This is saying they don't have to be equal, they just have to be proportional. And so I want to look at an example so that we know what that might look like. So if this triangle was 3 units, 4 units, and 7 units, go ahead and mark that down. And then if we have 6 units, 8 units, and 14 units, then these triangles are similar. And you can see that the scale factor here is 2, right? This triangle, all the side lengths are exactly twice as large as that one. And so these triangles are for sure similar. And we therefore know that all the angles are congruent because we know we're dealing with similar triangles. So I do want to just take a minute and write out the ratios here. So if we have small to big, we can put the small sides on the top. We would say that 3 to its corresponding side is equal to 4 and its corresponding side, which is equal to 7 and its corresponding side. So these three ratios are congruent. They all equal 1/2. And so because these ratios are equal, we say their side lengths are proportional. So angle, angle, that's enough. Side, 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 proportional, that's enough. And then the last one is side, angle, side. So again, this was a triangle congruence theorem, but this is different because this says if two sides of one triangle are proportional to the corresponding sides of another triangle and their included angles are congruent, then the triangles are similar. What does that mean? So let's say we only have two sides. Let's say we had the 3 and the 6 and we had the 7 and the 14. That alone would not be enough to know that our triangles are similar. We can see that this side is twice as big and this side is twice as big, so I know that those will form a proportion, but we need a little bit more information. If we knew these sides, awesome. But if we don't, we could just know the included angle. Let's say that's 50 degrees and that's 50 degrees. Well, that's enough to know that these two triangles are similar, side, angle, side. So we can say, look, we've got small to big equals small to big. That's proportional. We could even cross multiply to show 6 times 7 is 42. 3 times 14 is 42, so that's for sure proportional. And the included angles are congruent, and that means we're dealing with similar triangles. So we're going to use these 3 shortcuts today to prove that triangles are similar and also to find some missing information. So let's open it up and start with example 1. So it says, consider the diagram below. Prove, if possible, that these triangles are congruent. So what do we have? There are 2 triangles here, but they're all overlapping. If you want to, you can just work with this diagram, but I found that these sorts of diagrams are a lot easier if you draw the 2 triangles out separately. And so that's what I want to do right now. I'm going to take this triangle and just kind of sketch it and include the letters. So we've got R, and then right here that's letter S, and down here that's V. So that's my smaller triangle. And then next to it, I'm sort of going to draw a bigger triangle, R, and then T, and then at the bottom we have U. And so the question is, are those 2 triangles similar? Let me go ahead and label with what I know. RS is 10. Make sure you put that information on the correct triangle. SV is 8, so here's SV. TU is 12, that's over here on the big triangle. And then I was also given that the measure of angle S is congruent to the measure of angle T. Well, that's not enough information. So we need to think if there's one of the shortcuts that will work here. So the first shortcut was angle, angle. And I've got one pair of congruent angles, and I actually have another one too. So I don't know if you can see it, but angle R is in both triangles, and it has to be equal to itself, right? This is R, this is R. Both triangles meet in that corner. So that means angle R has to be congruent to angle R. So that's all I need. I've got AA. So I'm going to say, by the AA shortcut, angle, angle, these triangles are similar. That's simple. I didn't even need to go to the side lengths. So let's keep going. Let's look at part B. It says, if so, if they are similar, which they are, find the length of RT. So now it's asking for that length. So I'm going to set up a proportion. I'm going to go small to big equals small to big. So I think I'll do RS first, small to big. So RS, that would be X. Small to big equals small to big. So back to my small triangle, SV is 8. I'm always going to check the similarity statement here. SV corresponds with TU, which is 12. So I'd like you to pause the video now and go ahead and solve this proportion to find the value of X. So 8 times X is 8X. 10 times 12 is 120. We put an equal sign between them, and then we just divide on both sides by 8. Yeah. And we get 15. And that means the length of RT is 15. So first you have to prove that they're similar, because if you don't know they're similar, you can't set up a proportion because you don't know that the side lengths will be proportional. So there's example 1. Let's do example 2. Consider the diagram below. Prove, if possible, that these 2 triangles are similar. So AA is the easiest, and we should always look first to see if we've got 2 angles. So looking here, I can see that T and P are congruent, so there's one angle, and then the only other angle information I have is right here, this right angle. And so I want to look at the other triangle and see if it has a right angle as well, because if it does, I'm good to go. And I hope you can see that if this is a 90-degree angle, then this must be a 90-degree angle too. So these triangles are similar by AA. So yes, by angle, angle. So T and P correspond, and then S and S correspond, right? And you can see that if we sort of turn it, that triangle is a right triangle, and it is similar to that right triangle. They're just, the smaller one is turned on its side. So now that we know that they're similar, we can find the length, hopefully, of PQ. So we're looking for this PQ, just that length. This problem is a little bit trickier because the triangles overlap in ways that make it a little confusing. So again, I'm going to draw my two triangles out separately and turn them both the same way. I just find that easier. So why don't I turn the smaller one upright? So if I do that and make it look like the bigger one, I'm going to have a smaller one and a bigger one, and we've got right angles in both. Those are the angles that are congruent, so it's T on the small triangle, P on the big triangle. The right angles are both at S. And then on my small triangle, I have Q. And then on my big triangle, I have R. So I just find that a little bit easier. And then I'm going to go ahead and write in all the lengths that I was given. So TS is 15. Go ahead and mark that down here. SR is 12. Go ahead and mark that down here. QS is 9. And then we've got this like PQ situation, which is a little bit confusing. So I'm going to try to get this side, that's PS, that's this long side. I'm going to try to sort of figure out what's going on there. And what I've got is this side is divided. Part of it is 9. I don't know exactly where that hits. And then part of it is X, right? So the whole side together is actually 9 plus X. It looks like it's halfway up, but we don't know that. We can't assume. All we know is that part of it is 9 and part of it is X, and so the entire side together has to be 9 plus X. And so given that, I can now set up a proportion. I'm going to go small to big equals small to big. So why don't we start with the bottom here. So I've got 9 to 12 equals small to big equals small to big. Well, the big side length is a little complicated here. It's 9 plus X. So that's the proportion. 9 over 12 equals 15 over 9 plus X. And you could have done that without drawing the triangles separately. I just find it way easier. So this is not a super easy proportion to solve, but I'd like you to try it on your own. So go ahead and pause the video now, cross multiply, solve for X, and see what you get. So when we cross multiply, 12 times 15 is 180. So I'll go ahead and write my equation down here. I've got 180 equals, and when I multiply the other way, I have 9 times the quantity, 9 plus X. So I have to multiply 9 by that whole thing, and the way we show that is using parentheses. And then we have the distributive property. So I'll drop my 180 down. 9 times 9 is 81. 9 times X is 9X. And now I have a pretty simple equation to solve. Subtract 81 on both sides. 99 equals 9X. When you divide on both sides by 9, you'll get X equals 11. And let's double check and make sure that's what we were asked to find. It says find the length of PQ. I labeled that with an X, and so sure enough, PQ equals 11. Okay, moving right along, example 3. So So with example 3, it says, prove if possible that these two triangles are similar. So first I'm going to look for AA. And I'll just write down AA question mark. So I've got one angle, and that's it. And there's no information here that would lead me to find another one. So AA does not work. Looking back at our shortcuts, another option was side, side, side. Are the sides all proportional? Side, side, side. So I could set up a proportion here with these two corresponding sides, but this is side, side, side. To use this shortcut, I would need all three sides to be proportional, and I don't know what the third side is. That shortcut won't work. The last one is side, angle, side. So this is looking more promising because I've got two sides. But remember, this has to be the included angle. And the angles that I know are congruent are not between the sides that I was given, right? I would need this side, that angle and that angle to be congruent, and this problem didn't tell me that. So we don't know. We can't show similarity. They might be similar, we just don't know because none of those shortcuts work. So that's easy. Example 4. Example 4 says, prove, if possible, that these two triangles are similar. So let's start with AA. Let's see if that works. I can see right now I'm not going to. I don't have any angles. Yoink. Let's see if side, side, side might work. Okay, it might. So I've got three sides here, three sides here. So what I'm going to do is set up proportions and see if they work, or set up ratios and see if all these sides are proportional. So I'm going to start, I'm going to always go back to my similarity statement, GH and LM, and I'll start there. So GH, LM, and I'm going to set up that ratio. So that's 8/12. And I want to see, is that equal to, and I'm going to put a little question mark under it, is that equal to, let's go to the second letters, HJ and MN. Small to big. And then if so, I want to know, is that equal to my third sides? You go ahead and set up that ratio. So a little shortcut here, we could definitely cross multiply. Cross multiplying is really useful when we're trying to solve for a variable. Here we're not. We're literally just trying to see, are these ratios all equivalent? And so honestly, the easiest way to do it is to type each one into a calculator. 8 divided by 12, 0.66666. 10 divided by 15, 4 divided by 6, let's check and see. They're all the same ratio. So I'm going to go ahead and write this is 0.6 on repeat. This is 0.6 on repeat. This is 0.6 on repeat. So they are similar by side, side, side. All the side lengths are proportional. Okay, last example. This is a lot. Example 5. If NP is 6, find the length of QR if possible. So we cannot begin this problem. We can't set up a proportion to solve until we know that these triangles are similar, because if they're not similar, we're stuck. So let's look at our shortcuts. Let's check first to see if AA might work. I've got one angle here. That's all the angle information I have. So nope. Side, side, side. Let's check that one. I've got two sides here and two sides here, so that's not going to cut it. I don't have a third side. So let's check side, angle, side, and see if that might work. I'm feeling a little better about that one, because here I've got a side, and the included angle. And then on the bottom, I've got this side, this side and the included angle. So first I'm going to check and see if this works. The angle part I've got. Angles are congruent, it was marked. I need to check and see if those sides are proportional. So I'm going to take these triangles, and again, I really like to redraw them. So I've got on my smaller triangle M, N, P, 4, and 8. And then the challenge is figuring out what's going on here. So I'd like you to try to label this bigger triangle on your own. So what we've got is basically this bigger triangle is just flipped. So I'm going to kind of imagine what it would look like if it was flipped. The M would be here, that angle is marked. This would be the R, and this would be the Q. And then MR is 6. And then MQ is this whole line. And so I hope you can figure out that that whole line is 8 plus 4, which is 12. And already I can see that these triangles are similar because this is twice as long and this is twice as long. So they're definitely proportional. But for good measure, let's go ahead and set up the proportion to show it. We've got little to big equals little to big, 8 to 12. And we could either type both of these into a calculator to show that they're equal, or we could cross multiply. That's 48, and that's 48. And so that means our sides are proportional, the included angles are congruent. That means these triangles are similar. And so to finish this problem up, it says if NP is 6, find the length of QR. Find the length of QR. So we're going to set up a proportion to do that. And we have some choices because we actually have more information than we really need. So I'm just going to pick one side. I'll do this side. MN is 4. Small to big, 4 corresponds with 6. And that has to be equal to small to big, the one that I'm looking for. I'll use an X there. So please go ahead and solve this proportion, find out that missing length. Okay. 6 times 6 is 36. 4 times x is 4x. So I've got 4 times x equals 36. That means x equals 9. And so that missing length was 9. I went through these examples really fast today. Thank you for sticking with me to the end. These were long notes. What I'd like you to do now is go ahead, obviously type in your summary, but if you are able to, if you have glue with you, please go ahead and set up your notes, get this glued in your notes so that you don't lose it, along with the essential question today and your table of contents. And we're done.